Scattered across a windswept plateau in the Bolivian highlands, more than 12,000 feet above sea level, lies a scatter of stone blocks that has confused visitors for over a century. Some are shaped like the letter H, cut with interior angles so sharp and faces so flat that early 20th century explorers assumed a machine must have made them. And later, generations of documentary producers ran with that same assumption for decades without ever putting it to a real test. For decades, the only way to study these blocks was with a tape measure, a notebook, and a lot of guesswork, because most of them had been knocked off their original positions by earthquakes, looters, and 5 centuries of stone robbing, long before anyone thought to document where each piece had actually gone. Then researchers finally did what should have happened decades earlier. They scanned the blocks, digitized every surface down to fractions of a millimeter, and used that data to try to put the puzzle back together and settle, once and for all, exactly how precise this stonework really is. What they found wasn't the flawless, machine-perfect geometry that decades of documentaries had promised. It was something stranger and honestly more interesting, a level of precision that's real, but not remotely as impossible as the popular version of this story claims, sitting right alongside one specific detail that even the researchers who spent years replicating these techniques by hand still haven't fully cracked. Before getting into what the scans actually revealed, it's worth being clear about where this site sits and who has actually studied it, because Puma Punku has become one of the most distorted archaeological sites on the internet, and separating the real research from the recycled ancient aliens footage matters here more than almost anywhere else. Puma Punku is part of the larger Tiwanaku complex, a UNESCO World Heritage Site near Lake Titicaca, built by the Tiwanaku civilization roughly between 500 and 950 AD, meaning this stonework predates the Inca Empire by several centuries, contrary to how it's often lumped in with later Andean sites. The most detailed digital work at the site was led by archaeologist Alexei Vranic, in collaboration with researchers at UC Berkeley, using laser scanning, photogrammetry, and 3D printing to rebuild scaled physical models of the scattered fragments, published in the peer-reviewed journal Heritage Science. Separately, architect Jean-Pierre Protzen and archaeologist Stella Nair spent years conducting hands-on experimental archaeology at the site, physically attempting to replicate the stonework using only tools that were actually available to the Tiwanaku, with their findings published in the Journal of the Society of Architectural Historians. Between the digital reconstruction and the hands-on replication work, this is one of the most rigorously studied mystery sites in the world. It's just that almost none of that research ever makes it into the viral version of the story. So let's start with the geology, because the material itself is the first thing most viral claims about Puma Punku get wrong. The blocks at the site are made from 2 different stones: reddish sandstone, used for the larger foundational elements, and gray. Green andesite, a volcanic rock, used specifically for the finest, most precisely finished pieces, including the H-blocks. Andesite sits at roughly 5.5 to 6 on the Mohs hardness scale, genuinely tough material, hard enough that popular claims often frame it as effectively impossible to shape with primitive tools. But impossible was never actually true. It was just unproven, until someone put in the years of fieldwork required to test it directly. The sandstone tells its own part of the story too, and it's worth understanding both materials, because the Tiwanaku clearly weren't using a one-size-fits-all approach to their stonework. They were matching technique to material with real sophistication. Quarry sites at Cerro Capia and the Oahu Copacabana Peninsula, several kilometers from the main site, provided most of the raw stone. The softer, more workable sandstone was extracted using a groove and fracture method. Workers cut long parallel channels into the bedrock using stone hammers and abrasive sand, then packed wooden wedges into those channels and soaked them with water, letting the swelling wood physically split the rock along a controlled line. A genuinely clever piece of low-tech engineering that doesn't require anything beyond wood, water, and patience. The harder andesite required a completely different approach, since it's too brittle and dense for that same wedge-splitting technique to work reliably. Instead, it was shaped through sustained percussion using hafted, handle-mounted hammerstones, followed by grinding with flat sandstone plates and a wet sand slurry to achieve the mirror-smooth surfaces you still see today on pieces, like the nearby Gateway of the Sun. 2 different rock types, 2 entirely different extraction and shaping methods, both requiring specialized knowledge passed down and refined over generations, which is itself a detail that undercuts the idea of some singular, mysterious, unexplainable technique. What's actually on display here is a diversified toolkit of real engineering solutions, each one matched carefully to the specific material it needed to work. That's exactly what Protzen and Nair set out to do. Rather than theorizing from a distance, they physically sourced comparable volcanic stone and tried to replicate the H-blocks, features using only tool types that were realistically available to the Tiwanaku. Hammerstones made of harder minerals like quartzite, flint, obsidian, and hematite, none of which require metallurgy more advanced than what's already been documented at Tiwanaku sites. And it worked, using nothing but percussion and abrasion, literally striking the stone repeatedly with a harder rock, then grinding the surface smooth with sand, water, and a flat abrading stone. Nair successfully carved a scaled cross-shaped recess into andesite that closely matched the precision visible on the real H-blocks, achieving flat surfaces within roughly a millimeter of tolerance. It was slow-going, with some of the finest surfaces requiring what Pratzen estimated at somewhere over 200 worker hours per square meter to complete. But slow is not the same thing as impossible. Given the kind of coordinated labor a state-level society like Tiwanaku is known to have organized for other massive construction projects at the same site, that kind of time investment is entirely plausible. There's also a specific reason the harder stone tools actually worked here, and it comes down to something the popular impossible without metal claim usually skips right past. Bronze, as it turns out, is not actually the right tool for this job. The Tiwanaku did have access to bronze, and archaeologists have recovered bronze architectural clamps used elsewhere at the site to link stone blocks together structurally. But when researchers tested bronze tools directly against andesite, they proved largely ineffective, too soft to reliably remove material from a volcanic rock this dense. What worked instead were stones harder than the andesite itself. Quartzite and flint both sit around 7 on the Mohs scale. Obsidian fractures into edges sharp enough to cut with real precision despite being slightly softer. And hematite provided a dense, controllable hammering material for the roughing stage. That detail actually strengthens the case rather than weakening it. It shows the Tiwanaku weren't randomly experimenting with whatever material happened to be available. They had apparently already worked out, through trial and generational knowledge, exactly which specific stones were suited to which specific job, using bronze for the tasks it was actually good at, and reserving stone-on-stone work for the tasks that demanded it. Here's where the 3D scanning data actually adds something the tape measure surveys of earlier decades couldn't. When researchers digitized the tool marks left on unfinished and partially worked stones around the site, rather than finding evidence of a single, decisive cutting method, they found layered evidence of a 3-stage process. The roughest shaping stage left wide percussion marks in the range of 8 to 15 millimeters across, consistent with heavy hammerstone blows used to remove large amounts of material quickly. A second, intermediate stage showed smaller, more controlled marks, closer to 3 to 5 millimeters, consistent with lighter, more careful hammerstone work used to refine the shape. And the final finishing stage showed something telling. No distinct tool marks at all, just a uniformly smooth surface consistent with grinding and polishing, using an abrasive slurry that would have erased any evidence of the individual strikes underneath it. That's not the signature of a single laser pass or a one-shot machining process. That's the digitized signature of a repetitive, multi-stage human production process, refined the same way skilled craftspeople refine anything by hand, rough it in, correct it, then polish out the evidence of your own mistakes. This is really the core of what the scanning data shows, and it's worth stating plainly because it directly contradicts the most viral version of this story. The popular claim is that the H-blocks are identical to each other down to fractions of a millimeter, implying some kind of standardized mold or machine-based mass production. The actual digitized measurements tell a more human story. The blocks are extremely consistent, closely matching in overall dimensions in a way that shows real standardization and planning, but they are not perfectly identical twins of each other. There is measurable variation between individual blocks, small differences in exact angle, minor asymmetries in surface flatness, the kind of variation you'd expect from skilled human hands working from a shared template or measurement system, repeating a design many times over, rather than the zero variance repetition you'd expect from an actual mechanical stamping process. In other words, the scans didn't just fail to prove the impossible machine precision claim. They actively found the opposite, fingerprints of a careful, repeatable, but still fundamentally handmade production system. That distinction between highly standardized and perfectly identical turns out to matter more than it might sound like at first. A genuinely mechanized process, something stamped from a mold or cut on a fixed machine tool, tends to produce a very narrow, tightly clustered range of variation because the same physical constraint is limiting every single copy in exactly the same way. A skilled human process, even a highly disciplined one guided by careful measurement, naturally produces a wider, more organic scatter of small differences, because every single strike of a hammerstone, every pass of an abrasive slurry, carries a tiny amount of individual variability that a machine simply doesn't. When Vranich's team digitized enough blocks to compare them directly, the pattern that emerged looked exactly like that second kind of variation. Tight, disciplined, clearly guided by a shared design standard, but scattered in the specific, slightly uneven way that only comes from a living hand doing the guiding over and over, block after block, for however many years the finest sections of the site took to complete. There's also a scale of effort argument worth making here, because it's easy to underestimate just how large an undertaking Taiwanaku's stonework represents until you look at the numbers. Some of the largest blocks used elsewhere at the site are estimated to weigh well over 100 tons, quarried kilometers away and transported, without wheels or draft animals, suited to hauling that kind of weight to their final resting place. A feat that required its own separate body of engineering knowledge around sledges, log rollers, ramps, and coordinated human labor, likely involving hundreds of workers moving in careful, practiced coordination. The H-blocks themselves are far smaller and more manageable, generally under a meter tall, but they represent the opposite end of the same construction operation. Not the raw muscle of hauling massive stone across the landscape, but the extremely fine, patient, specialist labor of finishing that stone once it arrived. A society capable of organizing both of those things simultaneously. Brute force logistics at one end, fraction of a millimeter. Finishing work at the other is describing a level of centralized planning and skilled labor division that rivals plenty of better-known ancient civilizations that never get accused of needing outside help to explain their achievements. Let's pull that together for a second before going further, because there's more to this story than just debunking a myth. Puma Punku's H-blocks are made of andesite, precision-shaped using a documented 3-stage hammerstone and abrasion process that's been physically replicated by researchers using only tools the Taiwanaku actually had access to. Digitized 3D scans of the blocks show real, impressive standardization, consistent with a planned measurement system used across many stones, but also show small measurable variations between individual pieces, direct evidence against the popular claim of machine-identical, laser-cut precision. Now here's the detail that makes this story more than a straightforward debunking, because there's one specific feature at Puma Punku that genuinely has resisted full replication, even by the researchers most confident in the hand tool explanation. It's the deep interior recesses cut into some of the H-blocks. Precise, perfectly flat internal surfaces, tucked inside narrow channels carved into the stone with sharp 90-degree interior corners. Nair, during her replication work, successfully recreated the broader shape and the exterior precision of the H-blocks using stone tools. But she specifically noted that she could not fully replicate the perfectly flat interior surfaces of the deepest recesses using the techniques she tested, and she was candid about it in her published findings, speculating that a specialized tool, or a technique not yet identified in the archaeological record, may have been used specifically for that detail. That's a genuinely open question. It is not evidence of alien intervention or lost super technology. It's a specific, narrow technical gap in an otherwise well-explained process, the kind of unresolved detail that shows up constantly in real experimental archaeology, where a research team can successfully replicate 95% of a technique and still be left chasing the last 5%. It's the honest kind of mystery, bounded, specific, and actively being worked on, rather than the sweeping, all-encompassing mystery the internet tends to prefer. Now, the caveat section, because Puma Punku carries more misinformation than almost any other archaeological site on the internet, and it's worth addressing the two biggest claims directly rather than letting them sit unchallenged. The first is the geopolymer theory, most prominently promoted by materials scientist Joseph Davidovits, which argues that the H-blocks weren't carved from solid stone at all, but cast from a kind of ancient concrete, crushed rock mixed with a binding agent and poured into molds, which would explain the sharp, mold-like right angles. It's a genuinely interesting idea for materials science, and geopolymer technology has been seriously proposed and contested for other ancient sites too. But it hasn't held up specifically for Puma Punku under petrographic analysis, which examines the internal mineral structure of the stone under a microscope. That kind of analysis on the H-blocks shows continuous, naturally formed volcanic mineral grains and crystal structures consistent with solid, quarried andesite, not the more chaotic, mixed aggregate structure you'd expect to see in a cast or poured material. The tool mark evidence discussed earlier, the layered percussion and abrasion pattern building up in 3 distinct stages, is also much easier to explain as the result of subtractive carving than as the surface texture of a poured, molded material, which typically wouldn't leave that same kind of progressive marking underneath a smoothed final layer. The second major claim is the Ancient Aliens framing popularized by Erich von Daniken and repeated across shows like Ancient Aliens, which treats the precision of the H-blocks as evidence that the Tiwanaku either received outside technological help or that the site itself predates known human civilization by thousands of years, sometimes tied to disputed astronomical dating methods proposed decades ago by amateur archaeologist Arthur Poznansky. Radiocarbon dating of organic material recovered from Tiwanaku's stratigraphy consistently places the site's major construction phases within the first millennium AD, matching the broader archaeological record of the Tiwanaku civilization's known rise and decline, and showing no evidence of the abrupt, unexplained appearance that an outside help theory would require. The precision itself, once you actually look at the replication data rather than just the finished result, turns out to be a demonstration of exactly how sophisticated ancient Andean stoneworking traditions already were. Not a hole in the historical record that needs an exotic explanation to fill. It's worth sitting with why that distinction actually matters, beyond just correcting a viral claim. Framing Puma Punku as proof of lost alien technology doesn't just get the facts wrong, it erases the specific, well-documented human achievement underneath the myth. The Tiwanaku civilization organized labor, developed standardized measurement systems precise enough to be detectable in a modern laser scan, trained generations of specialists in a demanding multi-stage stoneworking process, and moved and shaped material this way at scale, at high altitude, using tools they made themselves. That's not a smaller story than the ancient aliens version. In a lot of ways, it's a bigger one, because it's actually true, actually documented, and actually representative of what a sophisticated pre-industrial society was capable of organizing and achieving, without needing to borrow credit from anyone or anything else. It's also a story that reflects something larger about how this kind of pseudo-archaeological claim tends to spread in the first place. Puma Punku's precision genuinely is remarkable. That part of the popular fascination isn't wrong. What tends to happen is that a real, striking observation gets detached from the years of unglamorous replication work that actually explains it, because archaeologists spent a decade carefully testing hammerstones, and measuring worker hours doesn't travel nearly as fast online as scientists can explain this. The gap between those two versions isn't a gap in the evidence. It's a gap in which version gets watched, shared, and repeated, and it's worth remembering that the boring-sounding answer is very often the one that's actually been checked. So here's where the science currently stands, and it's a more interesting resting place than either the debunked myth or a flat, it's just rocks dismissal. The digitized scans of Puma Punku's H-blocks confirm real, deliberate, standardized precision. Built through a documented 3-stage hand tool process that's been successfully replicated using only period-appropriate technology, and the small, measurable variations between individual blocks are themselves evidence against the impossible machine precision framing, not for it. At the same time, there remains one specific, narrow, technically unresolved detail, those perfectly flat interior recesses, that the most rigorous replication work to date hasn't fully cracked, and that honest gap is exactly the kind of thing that keeps this a live area of ongoing archaeological research rather than a closed case. Future scanning work and further replication attempts building on what Nair and Pratzen already documented may well close that gap eventually. For now, it stays open, tracked, and unresolved, which, if anything, is a far more honest kind of mystery than the one usually attached to this place. So, tell me down in the comments, does a real human-built explanation like this one actually feel more impressive to you than the alien version? Or does that one unresolved detail about the interior recesses still leave a little room for doubt? There's a real difference between a mystery that's actually been investigated and one that just sounds unsolved because nobody bothered to check. This is the first kind. Let me know what you think, and if unsolved details like this one are your thing, there's a lot more waiting for you right here.